Okay, everybody, welcome back and welcome to another exciting addition to the Programming for Engineers class. So this is part 2 of our segment of reading from files in C, third part of our file I/O in C installment. And where we left off last time is we looked at the basics in the last video of reading from a file in C. We looked at opening a file, closing it. We looked at using fscanf to be able to read in some different variables. But we had this problem last time. In the last video where we left off is that we had to know exactly how long the file was. We were reading in saying, I want to read in one integer or two integers, or I want to read in an integer, a double, and a string, or whatever the data types happen to be. And we had to know exactly how long the file was, or how it was, and how it was laid out, right? And so in this video, the focus is we want to think about a situation in which we do not know the length, okay? And we're going to look at two different versions of doing this, okay? And we don't know the length, and so the file might have maybe, a couple integers in it, or maybe it has a million integers in it, and we want the code logic to work regardless, okay? So we're going to be able to, which is a common thing, is that we don't know how long something is in the file, hence why we're storing something in a file to begin with, and we want our code logic to operate on that data. Okay, so just to kind of briefly recap, so we've looked at some of these common file functions previously. We looked at fopen, fclose, right? We also looked at fscanf, okay? And we've got these other ones in here as well, but I want to follow up a little bit where we looked at fscanf in the last video for reading data from a file into the program's memory, okay? But this time, we want to take it a little bit further, but we're still going to use the same function for reading in the data, okay? So I want to, if you recall, reading in something with fscanf, okay, it returns, if you notice it has this int type, that's the return type. If we look at the function header here, okay, it's got this return type of an integer, and this tells us how much information was read. Okay, did we read in one piece of information, two, or did we read in none, or did we have some sort of error come up which would return -1? Okay, so we have very common for a lot of functions that return integers that -1 is an indication of an error. Okay, so we want to look at this. Okay, I'm going to look at that in a little bit more detail, but let's break it down in a couple different pieces, and I'm going to come back to this piece. Okay, so here I've got a program, okay, and we're going to operate on this file, and it's called myfile2.txt. Okay, and this file here has this information in it. Okay, so I'm looking, I just opened up myfile2.txt, all right, and it's got these 6 integers in there. So before we even look at the code, let's just look at this file. Okay, this file's got 6 integers. This first integer in this case is telling us how large the file is. Okay, it's like almost like a bit of like header information, right, at the top of the file. It says, hey, there's 5 more integers in here, right? If I change this, right, and I had something else, like now I would change, that would have reflected there's 7 integers in here. Okay, right? So this file is giving us our indication of how much information is in there, with the very first variable or very first piece of information in the file is telling us how much information is in there. Okay, now you might look at that and say, hey, that's not ideal either, but we'll take it one step at a time. All right, so the first part of this is going to operate in a way that's very similar to what we've seen before, okay? Where we're opening the file, we're doing some error checking, we're making sure that the file was opened successfully, right? We're doing all that, okay? And down here, though, what we are doing is we're doing something a little bit different, okay? And what we're doing is we're saying, hey, let's read in here, let's read in the size of the array that we're going to populate. Okay, so what we're going to do, what we're really trying to do is we're trying to take this information, particularly these 5 integers, and we're reading them from our file system, from our hard drive, and we're literally loading them into memory, okay, into our computer's memory. Those 5 integers, Okay, so we're going from the file system to memory, right? This here is reads in that very first number, that 5, right? Reads in that 5 from our that very first integer that's in the file, okay? And then notice here we've got our heap memory allocation. We're using malloc memory allocation, and we're allocating enough bytes to store that entire array. Okay, now I want to point out something, right? This is dynamic. This is dynamic, and I use dynamic in the sense that this size that we're allocating on the heap adjusts based on that first integer value. Okay, it adjusts based on that first integer value. Okay, so if I have a bigger file or a smaller file, right, I'm going to adjust how much data we need to store in our heap memory accordingly. Okay, that's why heap memory is, and using these functions is often referred to as dynamic memory allocation. Okay, we're dynamically allocating it on the fly in the program's logic based on logic and information that's coming into our program. Okay, now what we should do, right, is it's very unlikely that this is going to happen, but we're looking at lines 21 through 24 here. It's just doing a little bit of error checking. It's saying, hey, you know, sometimes you could run into weird things where malloc could actually fail. It's very unlikely, but it could, right? And if we had a situation where that failed, we're just doing a little bit of error checking. We're closing the file, and we're returning with a -1 to indicate failure. Okay? All right. Now, what we're doing with lines 27 here through 31 is we are reading the file one at a time, okay, one integer at a time, and we are populating this array called user nums. Okay, so we're reading each line one at a time, populating it, because we know the length of the array, or we know the length of how many additional pieces of information is in that file. Okay, so we already know how, because we had at the very top here, we know that this is saying, hey, the array size is 5. Okay, we're going to have 5 more things in here. Right? So what this is doing, these lines here, is it's doing fscanf, it's going to the file, it's reading one integer at a time, and it is populating our array in memory. Okay, at that point, after that, we're done with the file. We can go ahead and close it. Say, hey, we don't need that file open anymore. We've already read it all into memory. Go ahead and close it. Okay. And then at the end here, all we're doing is we're iterating through the array, and we're printing everything out. Okay? We're just printing everything out in the array. It's using a while loop. We could have this as a for loop. It looks a little bit strange doing it as a while loop, but it's the same logic, right? It's just dumping all the contents of the array, right, from 0 all the way to array size -1, or less than the array size. Okay? Everything in the array, it's just printing it out to the screen. Okay? That's all that logic is doing. So if we run this, right, let's see, what do we get, right? If we compile it, this is called example 2. Okay, if we run this, notice we're printing out our array, these 5 numbers. Okay, and if I come in here and I change this, right, to have some additional information, to say make it of length 7 instead of 5, right? I don't need to recompile, right? ADAT is just executing it. I don't need to recompile. I can just run it, right? It's the same logic, and it'll automatically, based on the input data coming in, change how much space needs to be allocated. Okay, it'll automatically change how much space needs to be allocated. Okay? Now, one thing I'm noticing here, right, is we should also make sure that before our program quits, we should be using free to free up our heap memory, right? Deallocate heap memory. We should be coming here and saying, hey, this is our heap memory is using user nums, right? We should free that as well, right? So line 46 here is saying, hey, right, by the end, right, we're getting to the end of the program. We're no longer using that array that's on the heap. Let's go ahead and deallocate it. Okay, it'll be deallocated when the program terminates, but it's really good habit and proper practice that anytime you're allocating memory on the heap that you do in fact free it. Okay, so you might be asking yourself, right, right? If you're asking yourself, well, wait a minute, this is fine, this kind of works, right? But what happens if we're in a situation where it's kind of a pain to have this number at the top always have to tell us how long the array is? What if we want to get rid of that? Okay, what if we want to get rid of that and just have this thing work depending on how much stuff is in the file? Okay, so let's look at how we could do this, how we could do it that way, right? And there's a couple options that to actually make this happen. Right? For one, I want to introduce this idea of FEOF, right? Literally stands for file end of file, okay? And this lets us know, right? It's basically giving us a true-false indication. Have we reached the end of the file or not, right? Have we reached the end of the file, or is there more to read, okay? So FEOF, file end of file, lets us know if there's nothing left for us to read in. Okay, very helpful. Okay, here's an example, a common way of doing it. A common way of doing the file end of file is to say, hey, I want to keep reading, right? I want to keep using fscanf, right, until there is nothing left to read. Okay, so while we are not at the end of the file. So notice we have this that we've got the exclamation point for not. We're saying, hey, continue looping while we are not at the end of the file. So that's an example of actually applying that function and using it. Okay. Now we have this weird thing in here that I started kind of getting at a little bit before, but didn't fully complete the explanation of. The fact that fscanf, right? fscanf returns this integer here, right? It returns this integer. And that integer is a number of how much we have read, okay? How much have we read it successfully? So if we're reading one integer at a time, which is in the case in this example here, we're reading in one integer at a time, we would expect if this ran successfully that num read is going to be 1, okay? That num read is going to be 1, right? It's important we have this if num read equals 1 before printing something out, because when we hit the very end of the file, and we realize that there's nothing left to read, okay, fscanf is not going to return 1, right? I think it's going to return -1 or 0. It's going to be one or the other, either 0 that I read nothing or -1 indicating failure, okay? And what we don't want it to do is we don't want to add one incorrect value at the end of the array or print out one incorrect value. Okay. I'm going to show you an example of this. Okay, I'm going to show you an example of using FEOF and the fact of what is going on here with this fscanf and how we're checking this num read equals 1. Okay, my opinion, like always, is that I kind of put the topic out there and introduce it, and I kind of know that when you can't really understand it when you just hear it. Right? You have to see it, you got to see examples, you got to kind of work through examples, and really most importantly is after you've kind of been exposed to some examples that you actually try to build things applying this on your own, right? That's where you really learn it and where it really sticks, okay? All right, so let's take a look at another example, and I'm going to modify this a bit too, but let's just take it one step at a time. Okay, so this example here starts off very similar to what we've seen in the past. We're opening up a file, we're opening up file by file 2, we're checking for error to see if there's any problems, okay? And eventually we're closing the file and everything. And we've got these lines 20 through 25 here, which look really, really similar to the slide that I just showed, practically identical, right? Where we have this logic saying, hey, keep reading till we're at the end of the file, okay? Read one integer at a time, okay, and if num read equals 1, the return of fscanf, if it equals 1, go ahead and print it to the screen. Okay. Now, what that will do, let's run this. Okay, this is example 3. Okay, I'm compiling it, now running it. And notice that this goes ahead and prints all the stuff that was in my file 2. Okay, it goes ahead and prints all of it out. And it will change what it prints out if I change this, if I add other things, if I'm just typing in numbers here, right? Whatever I put in here, if I go ahead and do that, right? I come back and I run this program again, right? It's going to go ahead and it's going to dump out all that stuff to the screen, okay? And it's going to change based on the length of the file. It's going to change dynamically, right? It's going to based on the length of the file. Now, I'm going to change this just to make it super clear what's going on to just these values here, 1, 2, 3, 4, 5. Okay. And obviously, if I do that, you would expect that it's going to just print out 1, 2, 3, 4, 5. That's obvious, right? Now, I'm showing this though because I want to show what happens if I comment out. If I comment out that if numRed equals 1. Okay, and I'm actually going to change this even a little bit more. I'm going to print out here two things. I want to print out the value of numRed, okay, and the value of num, or file num, right? Okay, so I'm printing out two integers at each line, the value of numRed and the value of num. I want us to look at both. Okay, you'll see why in a moment. Now remember, before I run this, remember this file contains 1, 2, 3, 4, 5. Okay. Last time we ran it, before I made that change, we got to the screen values 1, 2, 3, 4, 5. Okay. Now, right, I'm going to have to recompile it because I made some change to the logic. I'm going to run it again. Okay, and notice on the right here, we're getting 1, 2, 3, 4, 5, and then 5 again. Okay, we have this extra little problem that came up at the end. Right? And the reason is it went in a loop one more time than you might expect, because file end of file doesn't really know you're at the end of the file, okay, until something runs and hits the end, okay, and that it knows that you've truly hit the end, that there's nothing left, okay. And in this case, it probably runs one more time in particular because I intentionally added a extra end of line here and there's no integer left, right? So you can see that there truly is like a line 6. Okay, so notice numRed, the return from fscanf, returned -1, indicating it failed. It was not able to successfully read another integer, okay? So that's why it's important that when we're reading it in here, that we check the return. That we check the return and say, hey, fscanf, check that it actually did what you expected it to do, so that you don't read an incorrect or inappropriate value. Okay? So besides a couple little nuanced differences, fscanf is working super similar to scanf, except for this additional input parameter here. Okay? And just being a little bit more cognizant of the output, right, the return, and how it's relating to hitting the end of the file. Okay. All right. Now, there's one thing we haven't done in this case, though. Unlike the prior example here that we showed earlier in the video, this example two used malloc, right? It allocated memory on the heap. And it allocated memory on the heap that in such a way that we read all the data for that array from the file, and we were loading it into memory. We were loading it into an array. Okay. However, right, example 3 here, we did not do that, at least not yet. Okay. We read the content from the file. We did not put it anywhere. Okay. We did not put that anywhere yet. Okay, let's go ahead and see how we can use this, how we can read something in such a way that we don't know until we don't know that we're at the end of the file until we hit the end of the file, right? Let's make this dynamic, right, where we are loaded, that the size of what we're loading in memory changes based on, as the file grows, the size of our array grows. Okay. So we're going to use dynamic memory again. We're going to use heap memory to do this. And I'm going to create a pointer for our array. Okay? And I'm going to set it to null. Okay? I'm going to set it to null. I also want to keep track of the size of the array. Okay, so I'm going to set size to 0. Okay, now what I'm going to do here, and we can go ahead, let's get rid of this thing that we added before. We can get rid of numRed. We don't need that. Okay, that we're printing it out. Actually, matter of fact, I'm going to get rid of this too. Okay. What I'm going to do in here is I want to add, the goal here is I want to add one more integer to the array. I want to add one more integer to the array. And to do that, I'm going to use realloc. I'm going to use realloc. And it's going to look like this. Okay. So what that line does is it says, hey, take this current pointer, okay, and when it's null initially, the first time this line runs, array equals null. When array equals null, realloc acts an awful lot like malloc. Okay, and it's going to allocate space on the heap, and the amount of space it's going to allocate is the number of bytes to store an integer plus the size of the array, right? And we start off with the size of 0, we say 0 plus 1. So we're basically saying the first time it runs, allocate space for one integer on the heap, okay? And we're going to say, okay, we're going to go ahead and we're going to add that, what we just read, which is file num. We just read file num. That's the value we got from the file. We're going to put it in that location, okay? And then we're going to add size plus 1. What this is going to do, right, is every time this runs, right, as we're going to continue looping as the file, right, as there's still integers left in the file, okay, and realloc is going to grow, right, is going to continue to grow the block on the heap, okay, based on if we're going to keep saying, hey, we need the array a little bit bigger, we need the array a little bit bigger, we need the array a little bit bigger, okay? Every time it runs, we're going to say, hey, we need a little bit more space, a little bit more space, a little bit more space, okay? That's what it's doing. So the first time realloc's called, it acts very much like malloc. After that, there already is a pointer, right, to the array that's allocated on the heap, okay? All right. So this should work, but before we're going to close the file because we're going to be done with it. At this point, after this runs, okay, we should have everything populated in the array. We're going to do a couple things though. We're going to close the file, okay? I'm going to free that memory before we leave the program, right? Because we want to be in that habit anytime you allocate anything on the heap to deallocate it. Okay, we have one block of data, that array, right? So we only need to call free once on that. Okay, and I'm going to do the following. I'm just going to loop and just print everything out that's in the array. Okay, just so that we know that it worked correctly. Okay. So let's go ahead and run this. Let's see if I made a mistake that we need to correct. Oh, and I did. Okay. And I think it's probably that I'm forgetting, doesn't like realloc. I think I'm forgetting a library here. Yep, I'm only including this standard IO library. Okay, let's include this, the standard library. I think that's where it is. Okay, let's try that. Compile again. and like that. Okay, let me clear the screen. So I've compiled it now. Let's go ahead and run it. Okay, and it seemed to run fine, right? It seemed to run fine. We can kind of test, add some more data here, whatever. Okay, right? At this point, it should run for all 7. I'm sorry, all 10 integers. All right, I don't need to recompile. The logic's the same. Okay, that went ahead and worked as well. Okay, so where you see files is a good example of using dynamic memory allocation because it's a good idea. Examples of when you're taking something that you could have any sort of different amount of information sitting in a file. You need to read in depending on that length, and you don't know ahead of time how long it needs to be, how big something needs to be stored. Okay, so using heap memory makes an awful lot of sense because you can adjust the size on the fly. Okay, just to kind of give you a sense of that, just to kind of combine this topic a little bit with heap memory, right? If I did it on the stack, it would look like something like this, right? And the problem is, if I allocated them in the stack like line 22, is you don't know how big to make that. Okay, you don't know what size to give that array at the beginning, right? If you don't know how big the file is, if it could be any size, it could be really tiny or really, really large, right? There's a tendency in that case to allocate a lot more space than you need, right? Which is very wasteful. And even then, you could still be wrong and still be too small, right? A lot of times people allocating space on the heap, they wouldn't do it just one integer at a time as it's growing because that in itself is also wasteful. They usually do it in blocks, say, okay, add another space for another 10 integers or another 100 integers and doing it in blocks. But I didn't want to bother with that logic right now. I could save that for another day. Okay, well, stay safe and healthy. Feel free to ask questions. Make sure to practice. All right, I'm going to make these code examples available to you so that you can be able to run them and mess with them and break them and change them up so that you can continue to learn and experiment. And other than that, right, stay safe and healthy. And once again, I will talk to you soon.